Good afternoon, students. So in this video, we will discuss how can we detect the polarization of the given light. If we have an unknown light and we want to find out the polarization of this unknown light, then how can we do this? So for this, we require two optical instruments. One is Nicol prism and another is quarter wave plate. So for this detection, we need two optical instruments. One is Nicol prism and second is quarter wave plate. So with the help of these two optical instruments, we can find out the polarization of the unknown light. Now what we do, first we pass this unknown light through the rotating Nicol. Rotating Nicol means Nicol is rotating about its axis. So we will first pass this unknown light through rotating Nicol. Rotating Nicol. Now on passing this unknown light through rotating Nicol, we can have three situations, or we can have three different cases. In first case we can have, or we can obtain two maximas and two minimas, and these minimas are with zero intensity. So when this unknown light passes through rotating Nicol, then in one rotation, during one rotation, we can have three situations on the emergent side. So first condition is, through the rotating Nicol in one cycle, on the emergent side we can have two maxima and two minima of intensity, and here this minima will be with zero intensity. So at the position where intensity is minimum, at that point intensity becomes zero. So this is the first case when on the emergent side we have two intensity maximas and two intensity minimas where intensity is zero. This is the first situation. There can be another situation, and in this situation we can have, or we can obtain two maximas and two minimas again, but here these minimas will be non-zero intensity. They will be non-zero intensity. Here we will get minimas, but their intensity will not be zero. So what we are saying, that when unknown light is passing through rotating Nicol, then on the emergent side we can get two intensity maximas and two minimas with zero intensity. This can be one case. Another case can be, we can have two maximas and two minimas with non-zero intensity. And in third situation that can arise here, this will be no variation in intensity. We can find out then during one rotation there is no variation in intensity. So no variation in intensity. So we can have these three situations on the emergent side when unknown light is passing through the rotating Nicol. So either we can have two maxima, two minima with zero intensity, or we can have two maxima and two minima with non-zero intensity, or there can be a third case where there is no variation in intensity. In this case, when there is no variation in intensity, or in this case when two maxima and two minima with non-zero, there are different possibilities. So in case when I am getting two maxima and two minima with zero intensity, in this case this unknown light will be plain polarized light. Here there is only one possibility. When when unknown light is passed through rotating Nicole, and on the emergent side, on the other side of rotating Nicole, we are getting two intensity maxima and two minima during one rotation with zero intensity, then the given light or unknown light is 100% PPL, plane polarized light. There is no other possibility here. But in this case, if we are getting two maxima and two minima, and this minima is of non-zero intensity, we can have three possibilities. First possibility is it can be elliptically polarized light. Either it is elliptically polarized light, or second is this is partially polarized light. This is partially polarized light. Partially polarized light is a mixture of PPL plus UPL. So this is a mixture of PPL, plane polarized light, plus unpolarized light. And third possibility is a mixture of EPL plus UPL. So there are three possibilities in this case. So when we are getting on the other side of rotating Nicole two maximas of intensity with two minima having non-zero intensity. So we are getting minima but their intensity is not zero. Then in this case we can have three possibilities. Either this will be elliptically polarized light, or this will be a partially polarized light, meaning a mixture of PPL plus UPL, or this can be EPL plus UPL, elliptically polarized light plus unpolarized light. Now in third case where we are obtaining no variation in intensity, so there are three possibilities. One is circularly polarized light. Here we can have circularly polarized light, we can have unpolarized light, or we can have a mixture of circularly polarized light plus unpolarized light. So these are three possibilities if on the other side of Nicole prism we are getting no variation in intensity. So first, what is the first step? In the first step, unknown light for which we want to find out the polarization, that light is passed through a rotating Nicole. When this light is passed through the rotating Nicole, then on the emergent side we can have three possibilities. In first possibility, we can have two maxima and two minima with zero intensity. So in this case, there is only one possibility, that is PPL, plane polarized light. But when we have on the emergent side, when we have two maxima and two minima with non-zero intensity, then there are three possibilities: elliptically polarized light, partially polarized light, or a mixture of EPL plus UPL. And in the third case, when there is no variation in intensity on the other side of the rotating Nicole, then there are three possibilities: circularly polarized light, unpolarized light, and a mixture of circularly polarized light plus unpolarized light. Now we will discuss all these three cases one by one. So in this case, there is no problem. We are sure here that the given light is unpolarized, is plane polarized light. So unknown light is plane polarized light. But here in these two cases, we have to find out that this is either EPL partially polarized or EPL plus UPL. So we have to distinguish. We have to find out a procedure with the help of which we can distinguish in between these three options. And similar case is here when there is no variation in intensity on the other side of rotating Nicole. So I am going to discuss all these three cases one by one. So first we will start with plane polarized light, and then we will move to no variation in intensity, third case, and then we will come to the second case. when we are getting two maxima and two minima with non-zero intensity. Basically, in this case, in second case and in third case, we will require quarter wave plate to distinguish in between these three different polarization of the given light. So what we will do, we will discuss one by one. So first case, what is happening in first case, if the given light, this is the given light, this is the given light which is passing through rotating nicole. This is passing through rotating nicole. So when this given light passes through rotating nicole, we get two maxima and two minima with zero intensity. So in this case, it will be surely plane polarized light. We have already discussed this case in case of nicole prism. How? If this is plane polarized light, then this plane polarized electric vector of this plane polarized light will make an angle with the principal section of this nicole prism. This is nicole prism. So this plane polarized electric vector of this plane polarized light will make an angle theta with the principal section of nicole prism. And when this angle theta becomes zero, when this angle theta becomes zero, then this plane polarized light will propagate through this nicole prism as E ray, and it will pass through this nicole prism, and we will get maximum intensity on the other side. The similar case will be for theta equal to 180 degree. So for theta equal to 0 and theta equal to 180 degree, we will get maximas on the emergent side or the other side of the nicole prism. And when the angle between the electric vector of PPL and the principal section of nicole prism becomes 90 degree and 270 degree, then the electric vector of PPL will propagate through this nicole prism as O ray, and it will undergo TIR, and on this side there will be no light that will emerge. So here intensity will become zero. So in this case, if the given light is PPL, we will get two maxima and two minima with zero intensity. So this is the first case. If the given light is passed through the rotating nicole prism, and we are getting two maximum intensity positions and two minimas with zero intensity position, then surely we can say that the given light is PPL. So this is the first case. Now second case, as we have already discussed, when the given light is passed through the nicole prism and we are getting no variation in intensity, then there can be three options. Either the incident light will be circularly polarized light, then or it can be unpolarized light, and it can be a mixture of circularly polarized light plus unpolarized light. So for the situation when on the emergent side of nicole prism we are getting no variation in intensity, then there can be three different polarized light which can satisfy this condition. Now we have to distinguish between these three different polarization state of the unknown light. So first we will pass this unknown light through a quarter wave plate. So we will pass this through the unknown light through the quarter wave plate. So there are three possibilities, and we are passing this unknown light through the quarter wave plate, and we want to check what will happen here. So when circularly polarized light is passed through the quarter wave plate, then it will convert into plane polarized light. Why this will convert into plane polarized light? Because for circularly polarized light, delta is equal to pi by 2. Delta will be equal to pi by 2, and this quarter wave plate will also introduce a phase difference between E ray and O ray, that is equal to pi by 2. Now these two phases will merge with each other, so either they will add or they will be subtracted. So either this will be pi by 2 plus pi by 2, or this will be pi by 2 minus pi by 2. So on this side we will have delta equal to either 0 or pi, and delta equal to 0 and pi is the condition of plane polarized light. So when circularly polarized light is passed through quarter wave plate, it will convert into plane polarized light with delta either equal to 0 or it will equal to pi. Now if we pass this plane polarized light, through the rotating nicole, then on this side we will have two maxima and two minima of intensity with zero intensity. So if a circularly polarized light is passed through a quarter wave plate, it will convert into PPL, and when this PPL will pass through the rotating nicole, this is rotating nicole prism. Rotating nicole, then on the other side of rotating nicole we will find out two intensity maximas and two minimas with zero intensity. In case of UPL, what will happen? When this UPL will pass through the quarter wave plate, on the other side it will remain UPL. Quarter wave plate doesn't change the polarization of unpolarized light. When unpolarized light passes through the quarter wave plate, it will remain unpolarized light. And when this unpolarized light passes through the rotating nicole, then on this side there will be no variation in intensity. Then it will be observed that there is no variation in intensity. So in case of unpolarized light, when it will pass through the quarter wave plate, it will remain unpolarized, and when unpolarized light is passed through the rotating nicole, then on the emergent side we will observe that there is no variation in intensity. In the third case, if the given light is CPL plus UPL, then this CPL, it will convert into plane polarized light. This will convert into plane polarized light, and this UPL, it will remain UPL. So what will be the mixture? Mixture will be like this. This is unpolarized light. Unpolarized light is like this. These are the electric vectors of unpolarized light. If plane polarized light is superimposed or mixed with this, suppose this light is here, this plane polarized, the direction of electric vector of plane polarized light is this, then these two directions are corresponding to maximum intensity and these directions are corresponding to minimum intensity. So intensity variation will be like this. And when we will pass this mixture through the rotating nicole, then corresponding to these positions, when this axis will become parallel to the principal section of the rotating nicole, we will get two maximas. And when this axis, this is smaller minor axis, when this is minor axis will become parallel to the principal section, we will get two minimas of intensity on the emergent side, on the other side of the rotating nicole. So when this PPL and UPL is passed through the rotating nicole, then on the emergent side we will get 2 maxima and 2 minima with non-zero intensity, So this will be the condition when these three polarized light passes through a combination of quarter wave plate and rotating Nicole. So if this is an unknown light and we pass this unknown light through the quarter wave plate and then rotating Nicole, and on the emergent side we are getting 2 maxima and 2 minima with zero intensity, then we will say that the given light is circularly polarized light. And if the given light or the unknown light passes through, after passing through the quarter wave plate and Nicole prism combination, we observe that there is no variation in intensity on the other side of Nicole prism, then we will say this is okay, this is unpolarized light. But in third case, when on the other side we are getting 2 maxima and 2 minima with non-zero intensity, then we will say this is a combination of circularly polarized light plus unpolarized light. So what we are doing here, first we are passing unknown light through a rotating Nicole, and if we are getting no variation in intensity on the other side, then we can have these three possibilities. Now to check out either of these three, which one of these three is present in the unknown light, we will pass this unknown light through a combination of quarter wave plate and rotating Nicole. And on the other side of Nicole, if we are getting this 2 maxima and 2 minima with zero intensity, then we will say that the unknown light is circularly polarized light. If we are not getting any variation in intensity, then we will say this is unpolarized light. And if we are getting 2 maxima and 2 minima with non-zero intensity, then we will say, okay, this is a mixture of CPL, circularly polarized light, plus unpolarized light. So this is the second case. Now come to the third case. Third case is when we are passing this unknown light through the rotating Nicole and we are getting 2 maximas and 2 minimas with non-zero intensity, then there are three possibilities. Either this is elliptically polarized light, or it is a partially polarized light, or this is a mixture of elliptically polarized light plus UPL. So now we are coming to the third case. Now come to the third case. So there are three possibilities in this third case. So either this is elliptically polarized light, unknown light is either elliptically polarized light, or this is a mixture of PPL, this is a mixture of PPL plus unpolarized light, or this is a mixture of elliptically polarized light plus unpolarized light. So in all these three cases, what we will observe, when we will pass all these three mixtures through the rotating Nicole, then we find out that there are 2 intensity maximas and there are 2 intensity minimas, and these minimas are with non-zero intensity. So now we have to differentiate in between these three cases. So this is EPL. EPL, you are all aware that this EPL can be of two types. Elliptically polarized light can be of two types. Either it can be rectangular ellipse or this can be non-rectangular ellipse. In case of rectangular ellipse, the major axis of the ellipse will be parallel to the optic axis. And in case of the non-rectangular ellipse, this major axis will not coincide with the optic axis. So first we will solve this problem. If we passes this rectangularly elliptical polarized light through the quarter wave plate, then it will convert into plane polarized light. But the problem is, if this is not rectangular elliptically polarized light and we passes this through the quarter wave plate, then it will remain elliptically polarized light. You can consider in this way, if this is elliptically polarized light, this is right angular elliptically polarized light, so here delta will be pi by 2, and when we will pass this elliptically polarized light through the quarter wave plate, which is introducing a phase of pi by 2, then here on this side we will have phase either 0 or pi. This will be pi by 2 minus pi by 2 0, or pi by 2 plus pi by 2 pi. So here on this side we will have plane polarized light. But this is the case for rectangular elliptically polarized light. But what will be the case when the elliptically polarized light is not rectangular elliptically polarized light? So this is the quarter wave plate, and it is introducing a phase of pi by 2, and here this is elliptically polarized light, and suppose delta is 63 degree. So on this side we will have delta equal to 90 degree plus 63 degree, or delta equal to 90 degree minus 63 degree. So in both the cases we will have elliptically polarized light on this side, because for right angular elliptically polarized light delta was already pi by 2, so on this side we will have PPL. But for another elliptically polarized light, delta can have any value. So for these values on this side, this delta will not become 0 or pi or 2 pi like this. So automatically we will have elliptically polarized light. So first we have to resolve this problem. So first what we are going to do, we are going to match the major axis of this elliptically polarized light with the principal section of the Nicol prism. So what we will do first, here this is suppose elliptically polarized light of any type, either this is rectangular or not, and we will pass this through this Nicol. We will pass this given elliptically polarized light, either this is rectangular or this is not rectangular. In both case we will pass this elliptically polarized light through this Nicol prism, and we will start rotating. We will rotate this Nicol, and we will rotate this Nicol up to the point when here on this side we have maximum intensity. Here we have maximum intensity. So now when we are getting maximum intensity on this side, then the major axis of this elliptically polarized light, suppose this elliptically polarized light is like this. This is like this. This is the elliptically polarized light. So when this major axis of this elliptically polarized light becomes parallel to the principal section, so when this major axis becomes parallel to the principal section of the Nicol prism, here on this side we will have maximum intensity. And we note down the position of the principal section of this rotating Nicol. So here we will note down the position of this principal section of rotating Nicol. Now we will place quarter wave plate. Now we will place this quarter wave plate parallel to the principal section of we will made it possible that we will place this quarter wave plate in such a way that the optic axis of this quarter wave plate becomes parallel to the principal section of this rotating Nicole. So first we find out the principal section of this rotating Nicole, we note down that position, and we will then replace this rotating Nicole by quarter wave plate in such a way that the optic axis of this quarter wave plate, is parallel to the principal section. When we will do this, when this condition will be satisfied, then what will happen? If EPL is incident on this quarter wave plate, then the principal or the major axis, of this EPL will become parallel to the optic axis of this quarter wave plate, and now this EPL will be the rectangular elliptically polarized light for this quarter wave plate. So what we are doing, first we will place this rotating Nicole on the stand, and the given light is passed through this rotating Nicole. So first what we are doing, we have a stand and we will place this rotating Nicole or this Nicole on that stand, and the given light or unknown light is passed through this rotating Nicole. We will rotate this Nicole up to the position when on the emergent side we have maximum intensity. That maximum intensity will be observed or will be obtained when the major axis of the elliptically polarized light will become parallel to the principal section of the rotating Nicole. We will note down that position, and then that rotating Nicole will be replaced by the quarter wave plate in such a way that its optic axis becomes parallel to the principal section of the rotating Nicole. Now what will happen here? So this is the first procedure. In this way, we will place this quarter wave plate in front of the unknown light. When this unknown light, if suppose the unknown light is elliptically polarized light, when this will pass through this quarter wave plate, then for this quarter wave plate, this will act as elliptically polarized light, and here on this side we will have plane polarized light. And now we can pass this plane polarized light through a rotating Nicole, and on this side we will have two intensity maximas and two minimas of zero intensity. This can be the first situation. In second situation, if we are passing the unknown light through the quarter wave plate, and this suppose unknown light is a mixture of PPL plus UPL. So what is happening? Now this is PPL plus UPL. So situation is like this. Suppose this is unpolarized light and a plane polarized light is mixed with this. Suppose plane polarized light has electric vector in this direction, so we have this type of situation. So this is the major axis of this partially polarized light, and this is also the direction of the plane polarized light. This is the direction of electric vector of plane polarized light. So when this plane polarized light will incident on this, then the electric vector of this plane polarized light will be parallel to the optic axis of this quarter wave plate, because we have already done this. We have already matched this major axis with the optic axis of this. So automatically the electric vector of this plane polarized light will become parallel to the optic axis of quarter wave plate. So now angle between the electric vector, now you can remember that the angle between the electric vector of PPL and this quarter wave plate optic axis is 0. So this electric vector of PPL light it will make 0-degree angle with the optic axis of quarter wave plate, and it will pass through this quarter wave plate as a E ray. There will be no O ray here in this case of PPL, so it will remain PPL. So it will not change, it will propagate through this quarter wave plate as a E ray. There will be no O ray, there will be no double refraction. So PPL will remain PPL and this UPL will remain UPL. So we will have same polarization as we have here on the incident side. Now we will pass this through the rotating Nicole. We pass this through the rotating Nicole, and on this side we will have two maximas, two minimas, and these two minimas are non-zero intensity. They are non-zero intensity, and the position of maxima and minima are the same as we have observed first. There is no change in position, no change in position of maxima and minimas in this case. So first we were passing the unknown light through the rotating Nicole, and we were getting two maxima and two non-zero minima. Whatever is the position there, the same position will be here. There will be no change in the position of maxima and minimas here. Now there can be a third case. It can be a combination of EPL plus UPL. So now in case of this EPL, which is we have already converted this EPL into the rectangular elliptical polarized light. So this EPL will convert into PPL plus UPL. And when we pass this through the rotating Nicole, we get two maximas of intensity, two minimas of non-zero intensity. But here positions of maxima and minimas will be changed. Positions will be changed in this case. So what is the difference between this and this case? In this case, the positions of maximas and minima remain same, which were obtained in the initial stage, but here we will get two maximas and two minimas of non-zero intensity, but their positions will be changed. So now I can summarize this case 3. If the unknown light is first passed through the rotating Nicole, so what we are getting on the emergent side, we are getting basically two maximas and two minimas with non-zero intensity. Now we have a situation that on the emergent side we have two maximas and two minimas with non-zero intensity. So we can have three possibilities. One is EPL, another is PPL plus UPL, and third is EPL plus UPL. To rectify this condition, or to find out which out of these three, which polarization is present in the unknown light, we will pass this given our unknown light through a combination of quarter wave plate and the rotating Nicole. And if on the emergent side we get two maxima and two minima with zero intensity, then we will surely say that the incident light is elliptically polarized light. If on the emergent side we have two maximas, two minimas with non-zero intensity, and their positions are not changing, their positions remain same, then we will say that this is PPL plus UPL, that the given light is PPL plus UPL. But if on the emergent side we are getting two maximas and two minimas with non-zero intensity, and their positions are changed, but their positions are not same which we have obtained initially, their positions are changed, then we will say that the incident light is EPL plus UPL. This is a mixture of EPL plus UPL. So in this way, in today's lecture, I have discussed how can you find out the polarization of unknown light. Thank you.